So hello everyone and welcome back once again to the today's session over the design of water tank with flexible base or flexible connection. Okay. So in the last session we have finished with the problem number 1 over the design of water tank, that is circular water tank with flexible connection. Okay. Now in today's session I would like to solve one more problem over the circular water tank with flexible base. Okay, so the given statement here, the design a circular water tank with a flexible base and open at top. So it is a flexible base and it is open at top for a capacity of 6 lakh liter. So the capacity of water here 6 lakh liter resting on ground. The height of water tank is 5 meter. The height of water tank is 5 meter. Okay. So we will consider that is the depth of water itself, because the free body is not given here. So in the previous session, previous problem, it was mentioned the height of free body was 200 mm. So here it is not given. So we will consider the height of water itself is 5 meter. Use FCK is equal to 30 Newton per mm square and Fy is equal to 415 Newton per mm square. So as I told you, after going through the statement, you note down the given data first. Okay. So we have the given data here. Given data. So they are given depth of water is equal to 5 meter. Okay, depth of water is equal to 5 meter and volume of water is they are given 6 lakh liter. So it will be nothing but 600 mm cube. By converting into meter we have mm cube. So therefore area of water, okay, water tank required, area of water tank required, it will be 600 divided by height 5. So it will be 120 meter square. Okay. So therefore dia is equal to D is equal to square root of 4a by pi. Okay, that is pi by 4 d square. By equating that you will get D is equal to, we get 12.36 meter. So we will have 12.5 meter. We will have the diameter of tank is equal to 12.5 meter. Then we have hoop tension. So now the next is hoop tension. Hoop tension along perimeter or periphery. It will be T will be gamma W into H into diameter divided by 2. Okay. So we have here 9.81 into H is 5 meter into diameter is 12.5 divided by 2. So we get here 306.56 kilonewton. So the hoop tension is 306.56 kilonewton. Okay. So now next is wall thickness. So for next is wall thickness. Wall thickness. Okay. So the wall thickness, the first of all, the AC will be equal to, as I told you, you have to remember this formula, 1000 into T minus M minus 1 into AST. Okay. So again the M is equal to modular ratio, which is given by 280 divided by 3 times sigma CBC. Okay. And for M30 grade, as per IS 456 or IS 3370, for M30 grade we get the sigma CBC will be 10 Newton per mm square. As I discussed, as I told you, you have how to refer the code to get the value of sigma CBC. You have to go back to you have to watch the previous videos to understand how to refer sigma CBC. Okay. So we get here the modular ratio will be 9.33. Okay. So therefore after getting modular ratio you have to find out AST. Okay. Also area of steel, required according to tension force. According to tension force, T is equal to sigma st into AST. Correct? T is equal to sigma st into AST. So from this you will get AST. So T is already we have calculated, so that is 306.56 into 10⁻³ divided by sigma st is 150. So we get the AST will be 2043.75 mm square. Okay, so we got the steel as per the hoop tension applied over the section, that is 2043.75 mm square. Okay, now we'll have AC is equal to again 1000 into T minus m minus 1. So we have got 9.33 minus 1 into 2043.75. okay. So this 1000 into T, so we will get 1000 into T minus 17024.21. so this I have named as equation 1. Next, the next step is now area of concrete required, as per hoop tension. So which is nothing but T is equal to sigma CT into AC. So again here, as I told you, for M30 grade, the value of sigma CT is 1.5 Newton per mm square. So again you have to refer IS. For this you have to refer IS 3370 part 2. I have discussed in my previous videos how to refer and how to get this value of sigma CT. Okay, so you can go back and you can check. Okay, so sigma CT into AC. So AC is equal to, here we get T divided by sigma CT. Okay, so this will be, T is again 306.56 into 10⁻³ divided by sigma CT is 1.5. okay, so we get here the AC will be 204373.33 into, sorry, this will be 2. I have named it as 2. Now what you have to do? You have to equate 1 and 2. Okay, you have to equate 1 and 2 and you have to find out the thickness. Okay, now equate 1 and 2 and you have to get the T. So by equating 1 and 2 we get T is equal to 221.39 mm. Okay, this is the thickness. Then we have again by empirical formula, also by empirical formula we have get another T. T is equal to, that is 30 times H plus 50. So we get this is 30 times 5 plus 50. It will be 200 mm. Okay. Now as I told you, you have to consider maximum of these two. Okay. Maximum of these two. So we will consider. So the maximum is 229. So therefore the T will be, so here it is 221.39. So we will consider 225 mm. So we'll consider T is equal to 225 mm. Now next we have AST minimum. Next we have AST minimum. Okay. So for AST minimum, T is equal to more than equal to 100 mm. We have 0.3% as I told you, and T less than or equal to 450 mm. We have 0.2%. Okay, so for T is equal to 225 mm, we get, after interpolation, we get here it is 0.26%. 0.26%. Okay, so therefore you get AST minimum will be 0.26 into 225 into 1000 divided by 100. So we get here the value will be 585 mm square. 585 mm square. So here you can write which is less than AST, which is less than AST, therefore okay. Which is less than AST, therefore okay. Now next we have to find out the bars with. So now here you have to find out the bar with spacing. So assuming 20 mm dia bars, if you assume 20 mm dia bars, okay, so we get the spacing will be 153.72. so I'll say 150 mm center to center. So we have to provide 20 mm dia bars, that is the rings along the periphery. So this ring will be of what? 20 mm dia bars of 150 mm center to center. So that you have to provide the rings in the tank, okay, like this. So that is 20 mm dia at 150 mm center to center. So therefore AST provided will be pi by 4 into 20 square divided by spacing into 1000 for 1 meter height. So this will be 2094.39 mm square. Okay, 39 mm square. So this is the main reinforcement in horizontal direction. Next we have the vertical reinforcement. The vertical reinforcement. Okay, so for that we have to provide AST minimum, that is 585 mm square. You have to provide the AST minimum. So for this again, assuming 10 mm dia bars, if I assume 10 mm dia bars, so we get spacing will be 134.2. So I'll say I'll provide 125 mm center to center. We can write. So hence provide 10 dia at 125 center to center. That is vertical bars. Vertical bars. Then next we have the check for maximum permissible tensile stress. Okay, which is again important. Check for maximum permissible tensile stress. Permissible tensile stress, which is given by sigma CT equal to T divided by 1000 into T minus M minus 1 into AST. Okay, so we'll find out here. T is given here 306.56, we have calculated already. Then we have divided by 1000 into thickness is 225 minus M M is, we have got modular ratio 9.33 minus 1 into AST is 2094.39, the provided AST 2094.39. So we get the permissible value of sigma Ct, that is 1.47 Newton per mm square, and which is less than the allowable stress 1.5 Newton per mm square. So this is the stress developed in the concrete because of the hoop tension. Because of the hoop tension, the stress developed in the concrete, and the allowable value is 1.5 Newton per mm square. So I will write here, hence safe. Hence it is safe. Okay, hence safe. Now we will go for the base slab, the reinforcement in base slab. Okay, then we will go for the curtailment. Okay, so next we have design of base slab. So as I told you, as the base slab rests on firm ground, so we don't have to design the thickness or the reinforcement. So we provide the minimum thickness and even the minimum area of steel. Okay, so as I told you, we can provide the depth or the thickness ranges from 150 mm to, in the previous videos I told you, we can provide the thickness of 150 mm to 200 mm. So I'll assume again the thickness of base slab as 160 mm. Okay, and the PT also you can provide, PT is equal to 0.3% in base slab. So these are the two assumptions, very important assumptions required in base slab. The thickness ranges from 150 mm to 200 mm and the PT is equal to 0.3%. Okay, so for thickness to 160 mm, the AST will be for 0.3% and thickness 160 mm, the AST will be 0.3 divided by 100 into 160 into 100. Okay, so we get here it is 480 mm square. 480 mm square, correct? So again, assuming 12 dia bars, so we get spacing will be 225 mm center to center in both ways. This is very important. Whatever the reinforcement you have got, those reinforcements should be provided in the both ways in base slab. Okay, in base slab. Now next we will move on to curtailment of reinforcement. Okay, that is hoop tension. Next is the curtailment of hoop steel. Curtailment of hoop steel. Okay, so as I told you, we have the water tank here for height 5 meter. Okay, so let us divide. You can divide with respect to your own distribution or the height we can divide. So I have divided the first 2 meter from top, then 1.5 meter, 1.5 meter, like that. So total is 3 meter. Understood? So this height will be 3.5. This height will be 2 meter. For 5 meter we have calculated and we have provided the steel. Okay, for 5 meter, for this zone already we have got the 20 mm dia at 140. So for this zone you have got 20 dia at 150 center to center. Now we have to find out the reinforcement for this zone and for this zone. That is called as curtailment. Okay, clear? So therefore again we have to prepare a table here. So first is hoop tension from top, that is in meter. Hoop height, hoop tension height, I can say height, this will be height, and this is the hoop tension T. We'll get it from This is gamma W into H into D by 2. Then we get AST, that is T divided by sigma ST, then spacing. Okay. So first of all add 3.5 meter height. So first of all for 3.5 meter height. So we get T is equal to here, that is gamma W 9.81 into H is 3.5 into diameter is 12.5 divided by 2. So we get here this 214.59 kilonewton, the T. And with respect to this, the AST will be, it will be T divided by, so 214.59 divided by sigma ST, that is 150. So we get this is 1430.62 mm square. Okay, so for again assuming 16 mm dia, we will get the spacing will be, S will be 140 mm center to center. Okay, so for this zone we got, okay, I would like to highlight that we got here, this we got 16 dia at 140 center to center, 16 dia at 140 center to center. I mean this zone up to this it will be 20 dia, this zone it is 16 dia. Okay, then next we have at height 2 meter, at height 2 meter. So we get the T will be 122.625 kilonewton. Okay, and also we get AST 817.5 mm square, and again by using 16 dia we get spacing will be 240 center to center. So the for third zone we got the reinforcement here, we got here 16 dia at 240 center to center. Okay, so here because of this the curtailment, the section has become economical, or the design has become economical. Correct na? You can see here, if you provide 16 dia at 150 throughout the height, it will be costlier. Okay, by making it curtailment we have made the section economic. Okay, so this is the end of the design of flexible, the design of circular water tank with flexible base. I have solved two problems. You go through, I request you go through all the videos, and in this if you get any queries, still you can contact me or you can write it over comment box. Okay, thank you very much.